This is day 17. Question number 1. Jazzy rode her bike at a constant rate for 9 hours. The table below shows how many hours she biked and how many calories she burned. How many calories did she burn per hour? Well, if it's a proportional table, you can select any of these. It really doesn't matter, right? So let's just pick up the easy one. So you can write 460 calories over 2 hours, and we want the unit rate. So the unit rate, divide top and bottom by 2, and you're going to get 460 divided by 2 is 230. So 230 calories in 1 hour. And we have letter A. Number 3, which set of data does not show a constant rate of change? So one of them is not what we call proportional. So let's go through them. So if you look at this one, the relationship is times 12, times 12, times 12. So this one's good. Times 5, times 5, times 5. So this is also good. Times 40, times 40, and then times 40. This is also good. They all match. So obviously the one that is going to give, it's not correct, is letter D. So you can tell here this one is times 5, times, obviously not times 5, because 6 times 5 would be 30, so we don't even have to go any further. Answer is D. 2. The employees at Tony's company worked a total of 489,623 hours last year, and they got paid. So I'm going to put hours at the bottom and the money on top. So they got paid 13,709,444. So find the unit rate, and again, this says closest, so it's not going to be an exact answer. So we just divide top and bottom. So how much did they get paid in 1 hour? Divide by 489,623. Divide by 489,623, and we should get an approximate answer. 137,09444 divided by 489,623. Enter. It gives me $28 an hour, and the closest one is this one. So back to question 4. So a football team is planning a trip to the beach where they will spend the nights in tents. If each tent holds 3 players, which table below correctly shows the number of tents needed for different number of players? Okay, so again, which table is, what do you call? So you know, so I'm gonna write 3 players. I'll create my own table here. 3 players would be 1 tent, right? 6 players would be 2 tents. 9 players would be 3 tents. So you're looking for something that looks like this. Okay. So 12 players equals 36 tents. No, it should be divide by 3. So 12 players would need 4 tents. So automatically this one is also. This one works, right? 12 players divide by 3. You get 4. Divide by 3, you get 6. Divide by 3, you get 7. 33 players. Divide by 3, you get 11. So B is the correct one. And just to make sure, I'll look at C and D. And again, this works out. 12 divided by 3 is 4, but 16 divided by 3 is not 2. That's garbage. 12 divided by 3 is not 6, so I don't even have to continue. That's also garbage. Okay, so this one, number 5, there's an issue because none of the answers that I worked out previously shows me the correct answer. So I'm going to do it anyway. So we have 3 quarts of soda. So if I mix 3 quarts of soda with 2.5 quarts of juice, I'm going to get, so imagine mixing those 2 up, I'm going to get a total of 5.5 quarts of punch, right? So if you want to make fruit punch, you mix this much soda, this much juice, and you get 5.5. So that makes sense, right? So now the idea here was the question says, what happens when you have 100 quarts of punch? So let's say you made 100 quarts of punch. How much juice did you use, fruit juice did you use, and how much soda? So this would be, find a multiplier. 5.5 times something is 100. So let's use 100 divided by 5.5, and that's going to give you a decimal, 18.18 repeated. So our multiplier is going to be 18.18 and 18.18, right? So we're going to multiply that. So we need to find out how many quarts of soda. So this is what we're interested in. So 3 times 18.18, right, is going to give us 54.54 quarts. So I would use 54.54 quarts of soda. And just, even though the question didn't ask, in terms of juice, is 2.5 times 2.5 times 18.18. That's going to give us, 45.45. And you can tell I'm correct because if I add these two, it's going to give me 100. But the problem is, this is here, but none of these say 54 or even 55. So just by default, because it's the closest one, I would choose this one. But there is the correct actual answer. It's not provided. So I'm thinking that whoever made this question did something wrong. Okay, so this one, make sure you know these fractional, proportions. So you can write 1/10 of a scarf. I can make in 4/5 of an hour, right? It takes 4/5 of an hour to make 1/10 of a scarf. I can be not even half of the scarf. Now, if I take 1 hour and I work for it for 1 hour, how much of the scarf will I have accomplished? Well, it's a fraction, so we're going to multiply this by the reciprocal, 5/4, right? You can see that all that simplifies to 1, so I multiply the top by 5/4. Multiply 1/10 by 5/4, you can simplify this, 5. 5 divided by 5 is 1, 10 divided by 5 is 2, and I can multiply across. 1 times 1 is 1, and 2 times 4 is 8. So final answer, D. So in 1 hour, I'll finish 1/8 of a scarf. 7. I use 5.5 tablespoons. 5.5 tablespoons of, tablespoons mixed to make 2 quarts of lemonade. 2 quarts of lemonade. At this rate, how much tablespoon? And this is my mix. Tablespoons of lemonade mix and makes 2 quarts of lemonade. Okay, so at this rate, what's the total number of tablespoons? So how much tablespoons do I need to make 3 quarts? So if I want to make 3 quarts, how much tablespoon mix will I need here? So find a multiplier, and you're better off, using leaving it as a fraction. So looking at 2 times a number equals 3, right? So I'm going to take that and replace it with a variable x. So 2 times the number equals 3, divide this by 2, divide this by 2, and x equals 3/2. So let's see if that works. So if the multiplier is 3/2, right? So 2 times this number over here equals 3. Is that true? Well, you can see that the 2's will cross out, right? This will cross out, this being a 1, and 1 times 3 is 3. So I have the right multiplier. So if it's 3.5, 3 halves, I'll multiply the top by 3 halves. So in your calculator, just multiply 5.5 times 3 halves. That's be 11/2 times 3/2. That's going to give me 33/4. 4 goes into 33 8 times, and I'm left with 1/4. Is there 8 1/4 here? Yes, there is. So final answer, I need 8 1/4 tablespoons of lemonade mix to make 3 quarts of lemonade. Number 8, Isaac practiced the piano 3 days a week for a total of 9.5 hours. On average, how many hours each day did he practice? So, how many hours? So 9.5, and I'm going to write 9.5 hours in 3 days. That's our relationship right now. And they're asking us in 1 day, how much did he practice? Well, divide by 3, divide by 3. So actually, I should not have done this. I should have actually left it as at 9.5. So 9.5 divided by 3. So let's change this over here. So 9.5 divided by 3. That's 18. 19 over 2 divided by 3. Remember, it's division. So I'm going to change that to 19 over 2 times 1 over 3, right? So that's multiplied by the reciprocal. So 19 times 1 is 19. 2 times 3 is 6. So 6 goes into 19 3 times, and 1 over 6. So it's definitely 3 hours. So this one's gone. So it's definitely 3 hours and 1/6 of an hour. So if you divide 1 hour into 6 parts, every part's going to have 10 minutes, right? So if you divide an hour into 6 parts, it'd be 10 minutes, 10 minutes, 10 minutes, 10 minutes, 10 minutes, 10 minutes, 6 times, right? So, and we want 1/6 of an hour. So it's going to be 3 hours and 10 minutes. Number 9. So again, half a gallon of paint. I can paint 1/6 of a wall. If I want to paint the whole wall, one entire wall, how much what do you call paint do I need? So again, it's 1/6, so times 6 over 1, multiply 6 over 1. These all simplify to 1. On top, half times 6 over 1 is 6 over 2, or 3. So I'm going to need 3 gallons to cover the entire wall. 12. The graph below represents the cost of gum packs at a unit rate of $2 for every pack. Okay, so every pack of gum that I buy of $2 for every, yeah, so right here. This is dollars, right? Over here is dollars. So if I pay $2, I buy 1 gum pack. The unit rates represents up $2 a pack, so that makes sense. $2 for 1 pack of gum. Represent the table using a relationship and an equation. So again, let's pick this value over here. This point right here is 1, 2, right? Where this represents the packs, and this represents the money. So let's find our constant proportionality. K equals y over x. Remember that this is the y and this is over gx. So k equals 2 over 1, or just k equals 2. So our constant proportionality is 2. Our equation, remember, is y equals kx, if it's proportional. Let's substitute y. No, let's leave y as it is, and then the k, I can replace it with 2. So this is our equation, right? The total I pay, find out the total I pay, which is represented by y. I multiply 2 times however many packs of gum I buy. So if I buy 1, it'd be 2 times 1, which is 2. If I buy 5 packs of gum, it'd be 2 times 5, which would be 10. So I can use this equation to find out. And then on the table, you can do something like this. Packs, money spent, right? So 1 pack of gum is $2, 2 pack of gums is $4, 3 pack of gums is 6, 4 is 8, and that's probably these 2 things is what they're looking for. 10. The athletic director of the school will distribute money from the budget to the fall sports, winter budget. So he's going to give away the money to fall sports, winter sports, and spring sports in the ratio of 4, 3, 2, respectively. The total budget for 3 sports season is $180,000. How much money will go to spring sports? So you can do a part total. So 4, 3, 2. Right, so yeah, part is here, another part is here, another part is here, and the total would be here, what, 4, 3, 7, so for a total of 9, right? Now, it's asking you, so if you had $9 right now, so what we can infer from here is that if I had $9, $4 would go to this sport, the fall sports, $3 would go to the winter sports, and $2 would go to the spring sports if I had $9. But I don't have $9, I have $180,000. So what's the multiplier here? Times 20,000, right? Times 20,000. So everything here is times 20,000. And this is also times 20,000. And we're interested in what? We're interested in the spring sports. Spring sports is the one that gets, this is a spring sport right here. So spring, 2 times 20,000 gives us $40,000. So they would spend 40,000 on the spring sport. $11. The ratio of child to teen to adult tickets sold at a water park was 4:1:2. So again, let me write child, teen, and adult. And this is total. So there was 4 tickets sold to a child, 1 to a teen, 2 to an adult. 5. Sum them up, I have 4 plus 5. So 7 tickets, 4 were to children, 1 went to a teen, and 2 went to adults. Right? So that's what I know. Now, if there were 294 tickets sold, how many of them were adults, how many of them were teens, and how many were then to children? So find the multiplier here. So on your calculator, you can simply go 294 divided by 7, and that gives us 42. So the multiplier is 42. So 2 times 42 is 84. 1 times 42 is 42. And 4 times 42 is 168. And you can tell if you're correct or not by adding this. So 168 plus 42 plus 84 should give you 294. The grocery store sells bean in bulk. The grocer's sign above the bean says 5 pounds for $4, okay? So 5 pounds, let me just write this somewhere. 5 pounds for how much? For $4. So Alberto said the ratio of number of dollars to the number of pounds is 4 to 5. That's 80 cents per pound. And the sign says that the ratio of number of pounds to the number of dollars is 5 to 4. That's $1.25 per pound. So one is comparing. So one is written this way, basically, and the other one is written this way. So in this case, they're putting the money at the bottom. So let's find a unit rate in this manner. So over here, let me bring that down. $4, I can get 5 pounds. So for $4 I can get 5 pounds, let's find the unit rate here. Divide by 5, divide by 5, which means 1 pound is 80 cents. Another way of looking at this is how much can you get for $1? So divide by 4, divide by 4, divide by 4, divide by 4. So for $1 I can get 1.2 pounds. And either way you look at it, it's the same. It's just written in different manner. So this one is comparing it to 1 pound. This is one's comparing to $1. So they're both correct. And B says Claude needs 2 1/4 pounds of bean. So how much money will he need? So we're talking about how much beans, right? So I would use this, the bottom one. So over here I can write if I had 2 1/4, the same thing as 2.25. So if I had 2.25 pounds, how much would I pay? So multiply top and bottom by 2.25, and that's going to give us $1.80. Now, if you look at the second question, Dora has $10. How much can she buy? So for that one, it's better to use this one on top, because if let me just write this over here, 1.2 pounds for $1. Right, so now if I set up a proportion, I have $10. Look how much easier. It's a $10. It's a times 10 relationship, right? So here times 10 relationship. So it means I can buy 12 pounds. So depending on what the question is asking, I can use this relationship or this relationship right here. All right. So the last one I'm going to ignore is a matter of preference. Okay. So this is how much Connor earns per week. In 1 week, he makes $15. In 2 weeks, $30. $3. 3 weeks, $45, and so forth. So we know it's proportional. The pattern continues. How much will Connor have earned after his 11 weeks? So in this one, you probably want to find the equation, okay, or find a relation, or create a table. So even if you created a table, weeks, money. So 1 week, $15. 2 weeks, $30. 3 weeks, $45, and that's given to us right here. So, and then we want to know in the 11th week how much money was he make. Well, find a relationship. It's times 5, times 15, times 15. So it's going to be a times 15 relationship. So that's going to be $165. Two more. Yep. Look at the graph. If the water continues to drip at the same rate, how many milliliters of water will have dripped at 14 hours? And again, you can find the equation, or you can find, to create a table or something to find a relationship. So what I know right now, and this is what I'll write. Hours, and this is volume, how much water is dripping. So right here, in 4 hours, it dripped 200. In 8 hours, it dripped 400. In 12 hours, it dripped 600. Can you find a relationship? If you can write, and then we can write 14 hours over here, right? So the relationship is time. Just divide 200 divided by 4, and you're going to get 50. So everything here is times 50 times 50. So the relationship here is times 50. So at 14 times 50, it's going to be the same thing. And you're going to get 700. So in 14 hours, you expect 700. Okay. Now, honestly, you could have just used the graph to get your answer. Last question. So the graph below shows the relationship between the distance measured in kilometers and distance measured in 1 mile in miles. So is there anything here that's precise? Which of the following is closer to the number of miles that's equivalent to 4 kilometers? So 4 kilometers. So the last question says the relationship between kilometers and meters. So over here, I'm looking at this point right here. So I guess in this one, we can just sort of estimate. 4 kilometers, I'm looking for this line right here. So what is this number right here? Well, I know the top line is 3, right? It's between 3. So it's going to be between, that's 3. So it's going to be between 2 and 3. And the only number that's between 2 and 3 is that one, 2.5. Okay, so that's an approximate. Okay, so this was day something, 18.